To our next presenter, we have Bob Kuzman, Executive Director in the External Affairs Central Region at MISO. He will discuss MISO's resource adequacy, evolution, and reliability imperative. Thanks for joining us today, Bob. I'll turn it over to you. Oh, Bob, we're not hearing you if you're talking.
How about that?
There you go.
There we go.
Gotcha.
Well, thank you very much for having me. I think I could say my presentation is ditto sort of to what you just heard from PJM, but just in different terminologies. But let's take a look, and if you don't mind going to the next page, that'd be great. So just a quick high-level view of MISO as PJM is. We are a not-for-profit RTO in 15 states and 1 Canadian province, Manitoba. We also have a very robust stakeholder process to help us maneuver through our filings at FERC and working through changes here at MISO. You can take a look at our generation mix as of January and through December of 2022. When I joined MISO 10 years ago, that mix looks significantly different with a lot more coal and not quite as much wind. We are seeing significant changes in that generation mix, which we're going to talk about. But one that has grown substantially here in MISO is also solar. It's been the largest growing over the last couple months, and we continue to see that growing each and every day. We have about 75,000 miles of high voltage transmission, and you can see our peak summer system is about 127 gigawatts. We have 3 locations, as people may know. We have a location in Minneapolis, here in Carmel, Indiana, and also down in Little Rock. So just a quick high-level view of MISO in a nutshell. Go ahead and go to the next slide, if you don't mind. I think I should look at this and sort of rename this and say all RTOs are entering a different operating and risk paradigm. What is one thing nice that maybe not nice, but what we have seen is not only PJM and MISO and SPP, but everybody across the nation is looking at the significant changes in our resource mix, the significant extreme weather, as the 2 slides on the top have to say, but also the change in how we operate our system and what resources our operators have each and every day to operate our system. I mean, yesterday, congratulations to the Philadelphia fans out in PJM. But even that time, it must have been a successful halftime show because we saw our operators putting a lot more supply on to meet the demand during our halftime show. So each and every day, the operators, the men and women that work down in our control rooms, both here and at PJM, are faced with different challenges because of the different types of load and also, more importantly, the different types of generation. You can look sort of at our fleet transition, what is retired and what we have added. Probably very similar to PJM's. You can see the coal starting to go away and gas and wind and solar being added. We'll talk a little bit more about the next slide later on my queue applications and what we're seeing in the queue. But I think it's important that MISO is still a summer peaking RTO. However, what we're doing is seeing more in the right-hand side. We're seeing more frequent emergencies called, and those are becoming more apparent in the shoulder months, the spring and the fall, and we're definitely seeing a lot more in the winter. What is important to go to help this is sort of the work we're doing as we see the changing resource mix, as we see supply side depleting, is the work that we're doing not only with PJM but SPP on SEAM's work to make sure that if one RTO has an issue, another RTO can help. So I know PJM and us will be announcing some plans here in the near future of a study that we're performing together. And I think it's imperative that everybody take away that the RTOs are working very closely together to make sure that everybody and all the RTOs keep the lights on. If you want to go to the next slide, please. So a lot of people have seen this, so I won't spend a lot of time on it. This is our MISO OMS survey, and OMS is the organization of MISO states who MISO works very closely with. Our states have resource adequacy authority. We have the reliability side of things. So each year we do a study, and we'll talk a little bit more about that. The slide I have on our planning processes coming up. But if you look on the left side, new capacity, or the blue portion of columns, is assumed at a recent historic rate of about 2.3 gigawatts. And the historic rate of build, we would nearly need about 3 more gigawatts short in the next planning year, or 7 gigawatts out in 3 years out, as you can see. Now, that doesn't count into what utilities decide to keep on the system rather than retire, and obviously other if we're higher than the 2.3. On the right side, you see more of an optimistic look. When we add, assuming 6.1 gigawatts a year of potential new capacity added, you can see that the short time frame falls apart. What we're doing to do that is trying to help our states with continued, as Jason talked, slow down the retirements, take a look at what resources can stay on later, and if you're replacing a retiring coal unit, replace it with something thermally based to make sure that we have that at this point. Now, it's very important to say that these numbers you see are for our present capacity accreditation. We do have accreditation for thermal resource at this point, but in 2028, we will start our new accreditation, which we'll talk a little bit about as we go further in the slides. One key factor that is not built into here, this is sort of a snapshot in time, is the additional load growth that we're seeing, which will take me to the next slide if you don't mind. So if you take a look at this, in the recent years, demand has largely been flat, 0.2% since 2010 to 2022. MISO is projecting growth greater than 60% through 2040. You can see that load growth is not only data centers, it's remanufacturing, it's green hydrogen, and it's electrification. So if you take that load growth, we really need to start building in how we can get these resources that are in our queue and PJM's queue onto the grid as quick as possible. I think my good friend Aubrey Johnson says the grid is hungry. It will take any type of resource at this time. So if you look at that chart, we are geared to a very significant load growth in the future. Now, we rely on our load serving entities to provide their load forecasts to us and take those and put those all together to look at our load forecast. But we are looking at an extremely higher load forecast in the next couple of years than we have had in the past. So with the idea of the supply growing, supply shrinking, and different resources, and the demand increasing, what has MISO done with our stakeholders and with our organization of MISO states to try to take a look at this? And I'll touch on a few high points on the next slide. So a few years back, MISO decided to come up with what we refer to as our reliability imperative. And if you look at the challenges, we've talked about a lot of those. Attributes need to ensure reliability, extreme weather events, large single site load additions, incremental load growth, fuel assurance issues, pipeline and energy infrastructure, and supply chain permitting issues to get delaying on these projects. I'm going to touch on a couple of them here, and then we'll also talk a little bit more as we go through the deck. This year, MISO has implemented the reliability-based demand curve for our capacity auction. This will be the first year that we will utilize it. So prices will be very interesting as we see, because before with the vertical demand curve, it was pretty volatile and could change rapidly. We're now looking at the first time that we're running a reliability demand curve with a slope to it. A couple years ago, we thought that the different types of resources that are coming into play perform better in different seasons, wind and solar, and some battery. So we decided a couple years back that we would have 4 seasons rather than just 1 or 2. So we will hold one auction for the spring, fall, winter, and summer seasons. And then some pricing reforms, which we're going to talk about, are later in the deck, and some of the forecast uncertainty. I will also talk about what we have done on transmission evaluation. But we also are working on system enhancements, which are very important to the reliability of the grids, fortifying cybersecurity, looking at advanced data analytics to hopefully predict weather and other aspects that could affect the grid. And then we're actually working on operations of the future of planning and preparing and working internally to try to solve some of these changing movements in the grid. You know, when I started at MISO 10 years ago, they said things don't change very fast in the utility industry. Well, they are changing at a rate that is incredible. And it's not 10 years ago, it's today. And we're seeing just rapid changes across our footprint. So let's talk a little bit about resource adequacy in some multiple time horizons on the next slide. So where we basically get a lot of our planning and sufficient resources is 2 things. One, as you can see on the left, uncertainty, the lower level, obviously at the real time and day ahead. And as we get farther out, it's more uncertain on predictability. So we look at obviously 1 year out, our resource adequacy planning auction horizon and seasonal resource assessments that we do, as we talked about. As we talked about earlier, the reliability demand curve will be the first time utilize this. And then I shared with you the OMS MISO survey, which sort of looks like 2 to 5 years out. And then MISO utilizes if some states require IRPs or other types of resource planning that our load serving entities and our members do, is sort of how we, MISO, take a look at planning for our future. So if you go to what other changes, I guess I should talk a little bit about on the next slide. Thank you. This slide is a high-level resource adequacy is measured of future reliability, and you need to measure it, and you need to target it. The metric we use called today is LOLE, or loss of load expectation, and that targets that that have used in the past 1 day in 10, meaning we build the resource and the model with the expectation that we may have an outage 1 every 10 years. What is MISO looking at to going to the future? MISO and Staples have been discussing the potential need to use a new metric, and the broader industry as well. One such metric would be EUE, or expected unserved energy, which is more precise about when and how big a potential loss of load may be. We're presently holding workshops and working with our organization of MISO states and other stakeholders to sort of take a look at, is EUE, or expected unserved energy, the new way we should start looking at our reliability criteria. If you want to go to the next slide. So the key part of what MISO has determined, and also our stakeholders, is sort of looking at what are the key components of resource adequacy. We talked a little bit about seasonal planning reserve margin requirements, local reliability clients, and local clearing requirements, and the establishment of LOE, the 1 day in 10. MISO has taken it upon us to take a look at accreditation. What are the resources really bringing to the capacity market? And we made some changes last year to our thermal units using seasonal accreditation-based operations, or we call it SAC here. So that has worked rather well for our thermal resources. We have seen our thermal resources perform better in those risk days when we really do need them. And we will be moving. FERC was approved our accreditation filing, and in 2028 we will be doing both our thermal and our renewables under DLLL, and using class average plus unit specific requirements to look at how those units perform and how does a class perform. We have also, and we'll talk a little bit later in the slide, worked on value of lost load. So those are some of the key components of resource adequacy that we have taken in as we see this changing resource mix moving through the system. And next slide, please. And this, I won't spend much time on this. This is sort of the timeline that we continue to move our resource adequacy construct to meet the needs of this changing paradigm, starting with annual, then we went to the seasonal RA construction. Then I talked a little bit about the seasonal accreditation, implemented the reliability-based demand curve, which starts this year. And finally, the target implementation, and that slide needs to be updated. We have filed and FERC has approved it, and that target implementation is 2028. We believe here at MISO that you need a good accreditation of the resources to have a very good capacity auction. Go to the next slide. This also talks a little bit about what we're doing to continue to enhance our probabilistic model. Recent enhancements of cold weather outage adder, planned outage, seasonal outage rates. Near time, what we're working on is better load forecasting, demand side evaluation, and then you can see what we're doing in the long term. So as we continue to see this resource mix change, we also have to look to change in how we look at our models and how we predict what tomorrow is going to bring us. Talk a little bit about our value proposition efforts and touch a little bit about transmission and generation interconnection. Go to the next slide. One after that. Thank you. There's a little bit about transmission. Obviously, we continue to need the new more transmission in MISO's footprint. A few years back, our board approved Tranche 1, which was about $10 billion worth of transmission. Those projects are now working through the state regulatory process and starting to get some movement of ground to improve those first $10 billion. This December, our board approved Tranche 2.2, which addresses MISO's Midwest subsection, the North and Central regions, and 24 projects totaling about $21.8 billion that will obviously provide excess benefits of that cost. We have built a 765 backbone into the Central and the North region to not only be more reliable, but also to attract that new generation that we're seeing spur up, that you're not seeing the large gas plants or coal plants, you're seeing the wind farms and solar farms. So we can make sure that those resources can get to the load centers as we continue to see the transition into renewables throughout our footprint. We have a interesting balance in our states. We have some states that have very high standard renewable standards, as Illinois and Minnesota have, and Michigan, and other states that haven't implemented renewable standards. So it's a balance to try to see and work with the states to make sure that we, as MISO, can help the states meet their renewable goals as we move forward. But this has a huge benefit for the North and Central region, the $21.8 billion of new transmission that is being built. And this doesn't talk about what we're doing with working with PJM and SPP in the future. Obviously, the joint project that we have, JTIQ, to help get specific generation on in the Missouri, in that area, Iowa area, is not part of the the $12.8 billion projects. Next slide, please. So Jason touched a little bit about RQ. We have if you think about it, MISO system is about 123 gigawatts peak. In 2022, we took in 171 gigawatts of new projects, and then followed up by 2023 with an additional 123 gigawatts of projects. So our queue is full. And our job now at MISO is try to get as much of that generation on the system as we possibly can. We've done a couple things that you probably have seen that has lowered that number from 171 to 123. Some queue reforms that FERC approved, the cost of getting in a little bit more land acquisition, more things to check the box before you enter our queue. But last month, FERC also approved our cap filing, which will allow us to cap out at about 70 gigawatts a year, which will allow us to study projects a lot faster and move those projects from signature on the GI to implementation a lot faster. Our goal is to have this queue somewhere in the next 3 years down to 1 year. And you can see the generation mix that is coming through our queue. We have a lot of solar, a lot of wind, storage and hybrid, either the wind or the solar, wind or battery, or solar and battery. We have seen an uptake in gas and other resources. But what Jason touched on a little bit is our replacement. So if you want to replace something in the MISO queue and you already have something on the system, call it 800 megawatts, you can replace that right there at that location without going through our queue. So trying to speed if there's a transition from coal to gas or transition from coal to battery and solar, that you do not have to come through the queue. You can utilize those interconnection rights that you already have once that resource is retired. Next slide, please. What else are we doing to do expedited projects? So as we continue to see this load growth, not only data centers seem to get all the attention, but there's a lot of remanufacturing coming home. Coming back to the States, we've seen that after COVID, that people are bringing their manufacturing back home and utilizing here in the States. So MISO has come up with a proposal called the Expedited Resource Addition Study, or ARIS. We plan to file it mid-March as we continue to work with our states to come up with their support of our states to move this process forward, because there is an acknowledgement that they will have to do at the commission level to tell us this is one of the projects that should be moved into the ARIS, the queue. MISO believes 3 years is appropriate. We will sunset it in December 31st, 2028. It allows time for GQs to reach a 1-year timeline. It provides an avenue for timely meet reliability and resource adequacy needs out in the real world as we see the load growth come in. So hopefully we will get this filed here mid-March and allow for those spot load growths or resource adequacy needs to be met with this ARIS, or it's not a queue, it's a one-off project study to allow that resource to get on to support that load growth as we see coming in the near future. Next slide, please. And as Jason also talked about, we wouldn't be here also if we would have some of these 55 gigawatts of approved interconnection requests built or on the system. And you can see about 26 gigawatts of those projects, what the delay is. Supply chain being the greatest, regulatory process, still negotiating power purchase agreements or other renegotiations, and also economic and financial changes. Obviously, after we changed the way we accredit resources, mainly solar, wind, and hybrid, that has affected some of these projects. And there's some economic decisions that those developers will have to make as we move forward. That is where we are. We're hoping to work with our states and our developers to try to get those resources on as quickly as possible. Next slide, please. MISO also made recommendations to change value of lost load relationships to the tariff. That is presently filed at FERC. Looking for that here in the next several months. But as you can see, our value of lost load is going up from 3,500 to 10,000. We have added a circuit breaker into our mechanism. So after 4 hours plus, that will value of lost load will diminish to 5,000. And if it's a multi-day, it will diminish to 2,000. I think this shows that that the idea of energy at a critical time, the true value of that energy. It's very important that we work with our states on this issue to come up with the cap and sort of the circuit breaker on our value of lost load. And finally, we wanted to touch on this. Won't spend much time on this slide. I provided a next slide. I provided a site at the bottom of it, but we basically have said, taking a look at our Renewable Integration Impact Assessment, or RIA, RII. And there's a site at the event. It's a great read. It's a very high-level understanding of what we see. But what we're finding is that once we get to about 30 to 40% penetration of renewables, the complexities increase and gets a lot more complicated for everybody. So it's important that we continue to implement these changes that we're seeing, not only based on the reliability imperative, but what we're doing on the pricing side and our systems, as we will soon potentially be at that 30 or 40% inflection rate. I encourage everybody to read it. I've included the site for that. At this point, I'll wrap up to allow enough time for questions here and go from there.
Thank you so much, Bob. That was a great presentation. And I can see what you had mentioned at the beginning. A lot of your presentation mirrored that of PJM's. You're seeing a lot of similar challenges. And it's interesting that they're extending from the mid-Atlantic through PJM over into MISO and across through the Midwest. But I really appreciate that you both added a lot of detail as to what your organizations are doing and a lot of what you're seeing. So that was really helpful. Thank you so much. And we do have a number of questions that have come in. The first one, I think perhaps both you and Jason both might have thoughts on, because it's a state that you share. So, and I know you talked a little bit, Bob, about Illinois and some of their energy policies that they have in place. And so the question is, what impacts do you think CEJA in Illinois will have on reliability?
Jason, you want me to take a shot at that?
Sorry, coming off mute. Yeah, Bob, if you want to go first, I'll follow you.
I'll go ahead and go first. Well, one, our goal is to make sure at MISO that we help Illinois meet its renewable standards. I think a couple things that we continue to work with Illinois on is obviously what we've seen in Tranche 1 and Tranche 2 to provide transmission, to bring resources in and utilize the resources that Illinois also has. The other thing is that as we continue to look at how we treat batteries, I know batteries is a large subject right now, not only in Illinois, but across the footprint, but especially in the Illinois General Assembly, taking a look at energy storage. And we're looking forward to working with Illinois to continue to meet their needs for their CEJA needs. I think as in the short term, I think Illinois is going to be fine looking at the MISO footprint. but we'll continue to look at that and see what assets they may need to bring on, and to continue the building of the transmission system out so everybody can share those resources throughout the footprint.
We're in a similar position at PJM. So we serve the ComEd service territory in the state, which is predominantly Chicago and its surrounding communities. Obviously, Governor Pritzker has some pretty ambitious climate goals, getting to 100% clean energy by 2050 for the state, 50% by 2040. And similar to MISO, we have a dedicated group at PJM called the State Policy Solutions Group. Their job is to help work with our 13 states to make sure that they are on target for their policies, whether they're clean energy and climate policies, or if they're policies for other aspects of their economy. So it's an aggressive bill. We're working very closely with them to make sure they get there. But we're also seeing that outside of Chicago, there's a renaissance of economic development, including data centers. That's going to take more power. It's just a matter of, can we find those resources and deliver that power in the time frame prescribed under the statute.
Great, thank you. This next question kind of goes along with that, but the question is, any thoughts about forecast demand or supply with current trends in the U.S. government and administration? Any thoughts or changes that you see coming with data centers, perhaps less wind that might come online? Anything you're looking at there, or is it too soon to tell?
I think it's too soon to tell. I think we're going to continue to see remanufacturing in data centers. It's just too soon to tell what changes will affect in this new administration.
And things are changing very quickly. We just heard about the new tariffs on steel and aluminum just yesterday. Earlier in the month, we heard that the president has paused the tariffs on Canada. There was a 25% tariff on general goods, but there was a 10% tariff on energy exports to the United States from Canada. So everything from coal, natural gas, as well as electricity. So we're still trying to figure out, obviously that has been paused for 30 days, but what the effects and impacts of that would be to those served in the PJM market. So as Bob just said, time will tell. Things are happening very quickly right now. We're trying to keep up.
Great, thanks. Bob, this next question is specific to you on slide 46, key initiatives, operations of the future. Here, let me get there really quick because my 46 is probably not the same as your 46.
That's the reliability imperative slide. Yep.
Yep. So the question is, can you, let's see, operations of the future. Okay, included situational awareness and critical communications. So that piece of it, can you explain a little bit more what that entails?
Yeah, it's basically internal. What situational awarenesses do we see? How can we be more warned of situations? And then the critical communications is, how do we make sure that we're communicating not only to our load serving entities and the generators, but also how to communicate to our general public.
Okay, great, fantastic. Okay, this next question is for both of you, Bob and Jason. So how does MISO and PJM marry the idea of trying to expedite new resources on the system and enhance resource adequacy, but also having a concern around the rising costs?
No, that's a good question. Obviously, when you're operating a competitive power market, you need to ensure that the price is sufficient to attract new investment in a climate where policies are changing very, very quickly. You see policies, at least at the federal level, will be shifting dramatically if you're to believe what the current administration is saying. And of course, we have 13 states in PJM, which I would say has more political and policy diversity than my colleague in MISO, in terms of states that still support their thermal resources and the economies that it supports, as well as states such as Maryland, New Jersey, and Delaware that have really aggressive aggressive and progressive energy and climate goals. So operating a state with operating an RTO with that degree of diversity in the states is a bit of a challenge. We think all of our policy proposals at FERC will make a difference to contain costs, but at the same time send a signal to the market that you'll be able to earn a return on your investment.
Yeah, I think we sort of addressed that when we were looking at our PRA auction as we move from the vertical demand curve into the more sloped or reliability demand curve, because 1 megawatt can send you to cone in a vertical where the reliability, it just adjusts price. It should send better price signals to our units. A little bit different than PJM. A lot of our units are vertically integrated, so some of those costs are already built into their rates and a little different than it would be set up in PJM. We're starting to see some gas units and a lot more battery coming into our system. So how we send those right price signals in the future is something we'll continue to work on here at MISO.
Great, thanks. Next question. Do new load requests, such as data centers, included in the load forecast have disincentives to submitting speculative requests, for example, readiness requirements with withdrawal penalties?
I think you're beginning to see that in some of our states as we approach this resource adequacy crunch. There's two solutions: build new generation or figure out a way to slow the connection of large load customers to the grid. So you're beginning to see some proposals come out from some of the large customers, as well as some of the states that are going to be requiring deposits, large deposits, to ensure that this load comes online, potential for take or pay contracts, as well as potential penalties if that load does not actually materialize. This is all still in its infancy. Up until now, the utilities have had an obligation to serve the customer who walks up, whether small or large. So there has been a paradigm shift in relatively short order. 24 months ago, nobody was talking about data center growth and this tremendous increase in our load forecast. So we're working on this together with those market participants who have vested interest.
Yeah, I can't add anything to that. Same.
Okay, great. And last question, somewhat along the same lines, do you have any comment on agreements with behind the meter generation serving a specific load?
So Bob, go ahead. So PJM has hit this issue recently. We've seen a lot of potential co-location requests, and I think that's a function of the fact that we have a large merchant fleet of nuclear generating units. So they make attractive targets effectively to pair up with some of these large customers, particularly data centers. PJM has tried to make clear that it has a preference that all network load, all customers be in front of the meter instead of behind the meter. So that's our general policy.
We haven't seen it as much, but we're starting to, and I think we're going to be working through our stakeholder process on how to address some of those needs.
Okay, fantastic. So that was all of our questions here for today. So thank you both for joining us, and thank you to our audience.